Okay, so here are some notes for the chapter 2 stuff that we were doing. So we're working on graphing different types of functions, and these are all the parent graphs that we've worked with so far. If you don't have these in your notes already, you should pause the video and write all of this into your notes. So we have all these different types here, and what we have to do first is we have to identify the type of what each of these shapes look like. Now we've already gone over some of these. Well, we've gone over all of these together, but if you've been absent, you may not have seen some of them. So just we'll go through each one. So the parabola looks like this. Okay, the red one here is the parent graph without any stretching or shifts, and then the blue one here is the graph shifted. So if we go back to the notes here in the graphing form, the h that we have in our expression here is a horizontal shift, either left or right, and the k is the vertical shift. And hk is the locator point, locates in this case the vertex of the parabola. So whatever number you have in here for h, it's x minus h. So if it's x minus 3, then 3 would be the location of the x coordinate of the vertex. And if k was 5, then 5 would be the y coordinate of the location of the vertex. So that's what the parabola looks like. I'm just going to continue again. Pause the video at any time that you want to go through this more slowly. The cubic graph, let me turn that off, looks like this. Okay, again, the red one is the parent graph, and the blue one is the shifted graph. I don't have any stretch put onto this graph. I just have a shift over um, uh, to the new locator point HK. And the HK has the same function. Back over here, H is the horizontal shift and K is the vertical shift. And you have to be able to recognize when you see this shape of graph. For now, it's going to be a cubic. Um, and so you just got to learn to see that. Let's go through a few others. The square root graph is this graph here. Red, again, is the parent graph, and the blue graph is the shifted graph. I could drag this around if I wanted to here and move that, change the value of h and k, but it still has the same shape. Okay, so the graph, for the square root graph up here, I didn't have a stretch factor on that one, but x minus h plus k, h and k give you the locator point where the graph's going to start. And you want to learn to recognize the shape when you see it. The absolute value graph looks like this. Okay, and again, the vertex here gives us is given by h and k, and so that's what that form looks like. And the latest one we got is the hyperbola or reciprocal. Most teachers use hyperbola as the name of this graph. I like also to call it the reciprocal graph because that's what we're doing to the input. We're taking its reciprocal, if you remember what that means. For a fraction, it means we're just flipping the fraction over. So if the fraction is 2/3, the reciprocal would be 3/2. So this is a reciprocal graph. Now let's take a look at the reciprocal graph. The reciprocal graph has a lot going on, or the hyperbola here. I'm going to turn off some things for a moment. I'm going to turn off all the green stuff, the shifted graph. Um, that HK there is part of the shifted graph. There's something that's a little bit wrong here real quick. That's y equals 0. This should be a dashed line, so let me fix that real quick. So this is the shape of the parent graph. Again, please ignore the HK over here. That goes with the shifted graph. So the hyperbola or reciprocal graph has what we call two vertical asymptotes. Or sorry, two asymptotes. One is vertical and one is horizontal. So you see this vertical dashed line going up and down right on the y-axis here. That's at x equals 0. I know it's on the y-axis, but any vertical line has the equation x equals a number. And since all of the x coordinates on this vertical line are 0, this is x equals 0. And it's dashed because it's not really as part of the picture, but it indicates what's happening to the graph as